Bismillahirrahmanirrahim. Welcome to MIT. Today we are going to solve some of the trigonometry questions from different past papers. The first question I have picked up from the question 0606/21 May June 2024. Well, let's see the first question. The first question is, show that tan x plus sec x whole squared can be written as 1 plus sin x over 1 minus sin x. That means we will have to convert this tan x plus sec x whole square as 1 plus sin x over 1 minus sin x. Look, I have already solved the question, because if I simultaneously write and explain, it will be the wastage of your time, and I strongly believe that all of you are very brilliant and more brilliant than I am. So if I just take huge time for explanation of tiny and simple parts, that is the wastage of your time. That's why, to save your time, I have already written it over here. Just I am going to explain or clarify some of the confusions which may arise in your mind, because I believe that all of you know how to solve the fundamental solutions of trigonometry. So the question is tan x plus sec x whole squared, and we know tan is equal to sin x over cos x, plus sec is actually inverse of cos. So sec is equal to 1 over cos x whole squared. Then in the next step we have just simplified this. Cos and cos denominator is same, so we have written the same denominator. Then if we simplify, I mean doing LCM, we will get sin x plus 1 whole square. So this is our step. Then next step is over here, sin x plus 1 whole square, we have left it unchanged, 1 plus sin x whole squared, and individually we have written the square. Look at this. Initially 1 plus sin x whole square over cos x square is equal to, we know that cos square x is equal to 1 minus sin square x is equal to cos square x. So instead of cos square x, we have written 1 minus sin square x. Then in the numerator, it's 1 plus sin x whole square. Whole square means 1 plus sin x into 1 plus sin x. That means same quantity has been written two times. And here we have applied a formula, an algebraic formula. The formula is a squared minus b squared is equal to a plus b into a minus b. A minus b, just the simple formula. So here a is 1, b is sign, so a plus b into a minus b, a plus b into a minus b. After that we have just done dissolution or cancel out. Look, 1 plus sin x can cancel out the another 1 plus sin x. So ultimately there remains 1 plus sin x in the numerator and 1 minus sin x in the denominator, which they have told us to show. So we have shown this. That's why the notation shown can be written over here. Let's see what the question number B says. B is actually the same question as the previous one. Look at this. This is written over here, tan 3 theta plus sec 3 theta whole square equal to 6. So the change we have got over here, if we go back to our question, we will find that this is, here it is written tan x plus sec x whole square. That means original function of tan and sec. So tan x, instead of x, they have given us here 3 theta. So what is the change we are going to make? Where there was x, we will just substitute it by 3 theta. So let's start solving. Tan 3 theta plus sec 3 theta whole square equal to 6. So in the previous question actually it was x. So instead of x we are just substituting it with 3 theta. Okay, instead of x we are writing 3 theta, but exactly the expression is similar to the previous one. And we know tan x plus sec x is equal to this, we have already proven 1 plus sin x over 1 minus sin x. So we have written 1 plus sin, instead of x we have written 3 theta, instead of x we have written 3 theta, 1 plus sin theta over 1 minus sin theta. Then if we do cross multiplication, 6 will multiply the denominator, and 1 under this there is an 1, invisible 1. So this 1 will multiply the numerator. If we do so, so if 1 multiplies the numerator, it is going to be 1 plus sin 3 theta, and if 6 multiplies the denominator, it is going to be 6 ones are 6, 6 sine 3 theta. Now 1 sine 3 theta and positive, if 6 is transposed to the left side, it is going to be positive. So 6 plus 1 is equal to 7 sine 3 theta equal to, and 6, if we transpose this one to the right side, then it is going to be negative. So 6 minus 1 is equal to 5. Ultimately, what did we get? 7 sine 3 theta equal to 5. Let me write it. I have written it just beside this. Now we are going to transpose this 7. If we transpose this 7 to the right side, what will happen? It is going to be 5 over 7. So ultimately we have got sine 3 theta is equal to 5 over 7. Means 3 theta is equal to, if sine is transposed to the other side, it is going to be sine inverse. That means sine has been transposed over here, as whenever sine is transposed from one side to the other, it will be inverse, sine inverse of 5 over 7. So our root is 3 theta, and our value is domain is sine inverse of 5 over 7. Okay, now at this stage, whenever we, let's see this curve, or not this curve, we can see this curve. This function is actually a transformed function. That means original function is sine theta. Look, we know sine theta, the values for sine theta or graph for sine theta, but this has been enlarged with the factor 3. So this is not the original function. Now whenever we find the function which is transformed, whether this is translated or enlarged or any other ways, then we will have to find out the domain. The given domain should be redefined, because given domain is given for original function sin theta or cos theta, but whenever the function is transformed, then the domain will get changed. That's why we are going to redefine the given domain. Let's see what the domain is. The given domain is 0 until 180, and all of the values are positive. So let's redefine this domain. Domain is 0 to 180. Okay, 180 degree. As it has been multiplied by 3, look at the left side, it was actually, our domain is actually now 3 theta. Our root is not theta, it's 3 theta. So we will have to multiply all the sides by 3. It is going to be 0. If we multiply by 3, it is going to be 3 theta. And if 180 is multiplied by 3, it is going to be 540 degree. So this is our real domain for this stage. Let's see, our value of the theta will be, means a value of the root will be 0 to 540, and all of them are positive, there is no negative value at all. Now we will have to, using our calculator, we will find how much is the value of sine inverse of 5 over 7. Using your calculator, you can find sine inverse of 5 over 7 is actually 45.58. This is the actual value. So our basic angle is 45.58. Now as it is positive, look at this, our value is positive, this one is positive value, we should know that which quadrants contain the values for sign positive. Sign positive values are, let me show you through the drawing. So this is our quadrants, and we know for positive value of sign the angle falls. Once again let me repeat, this is actually for positive value. Look at this, 5 over 7 is positive value. So for positive value we will move only in anti-clockwise direction. Remember, for positive value we will move anti-clockwise direction, for negative value we will move clockwise direction. And for sign positive value the angle falls over here or over here in the first or second quadrant. Either the angle is this, and the measurement of the angle we have already found it, 45 point, using calculator we got 45.58. 58. Well, this is 45.58. Well, now either angle will be this portion or angle will be this portion in anti-clockwise direction. Once again I am repeating, we cannot move in clockwise direction because there is no negative range. The sorry, this is negative domain. As the domain is positive, so look at this, domain is from 0 to 540, means in positive direction. Positive direction means anti-clockwise direction. This this domain will determine whether we can move on clockwise direction or anti-clockwise direction, positive or negative. Remember, anti-clockwise direction is positive and clockwise direction is always negative. The domain is actually, all of the values of this domain is positive, so we can only move in anti-clockwise direction. So in anti-clockwise direction if we move, then what are we going to get? Let me erase some of the part. Well, so angle is this one, 45.58, we have already written over here. Now the question is, if the angle falls in the second quadrant, then what will happen? It will be from for second quadrant, angle is actually starting from here to here. So we can write it better, from here to here. Okay, and we know the total sum of the second quadrant is 180. From 180 if we subtract only this portion, this 45, then we will get the optimum value. So we have subtracted, look at this, here we have subtracted 45.58, means this one has been subtracted from whole 180. Okay, now let's see, our domain allows 540 also. 540, how can we get 540? We can move this way, this way. Okay, well, so for this way again we are moving on to the first quadrant. So for the, what is the value if we complete one cycle, I mean in the second cycle, what is the value of the first quadrant? It will be up to this, look at this, up to this it is 360 in the fourth quadrant. Then it is getting more up to, just like up to this, so it will be 360 plus 45.58. Then again we can move on to the second quadrant. So if we move on to the second quadrant, we got that up to this it is, up to this it is 360, so up to this it is going to be 540. That means total 6 quadrants, here 4 quadrants, here 5, here 6 quadrants. So from 6 quadrants we will subtract only this angle. Okay, this angle should be subtracted, this is 45.8. so what are we going to get if we subtract 45.8 from 540? It is 16. Let me write. If we divide 45.58, there is a 3 on the left side. If 3 divides the first quadrant, I mean first value, it is going to be 15.2. And from 180 if we subtract 45 and divide it by 3, it will show 44.8. For this case you can use your calculator, it will be better and simpler for you. Then the third value is 360 plus 45.58, if it is divided by 3, because 3 is on the left side in multiplying state and on the right side it will be division. If you divide by 3, you will get 135.2, and the last value subtracting 45.8 from 540, if you divide it by 3, you will get 164.8, and there is no more value applicable for this domain. So what I am going to give importance is that the domain is the key role player in this case, because the original graph in the most of the cases, most of the past papers, you will find the graph is not as it is original. Always the graph is given transformed graph, sometimes translated, sometime enlarged, sometime shrunk or compressed. So whenever the transformed graph is given or function is given, then first of all we should know the domain, okay, or the value of x. If we can determine the domain, then we will decide that in the first quadrant and second quadrant. Look, let me show you. Here sine is sine, not sine, everybody sine cos, everybody is all the angles are positive in the first quadrant. In the second quadrant only sine is positive. In the third quadrant tan is positive. In the fourth quadrant cos is positive. So this is ASTC. All students take Cambridge. In any way you can get it memorized. So the first quadrant is positive for every angle. Second quadrant is for only for sine and cosine. Then third one is positive for tan and cot, and fourth quadrant is positive for cos and sec. After that we will decide whether we should move in the anti-clockwise direction or clockwise direction. Anti-clockwise direction, it means positive. If your domain, look at this, if your domain is positive, then only you can move in anti-clockwise direction. But if your domain allows any negative value, then you can move in clockwise direction. So in short, for anti-clockwise direction you should have positive value, for clockwise direction you should have negative value. I think you have understood at least as much as possible. Let's move on to the next question so that you can understand it better. This question belongs to 9709/12 May June 24. Actually, this is a question of A level, all of you know. A level paper 1, variant 2. And for the session May June 24, let's read the question. Show that the equation 7 tan theta over cos theta plus 12 is equal to 0. Let us write this once again. 7 tan theta over cos theta plus 12 equal to 0. 7 sin theta over cos theta. Tan theta is equal to what? Tan theta, we know tan is equal to sin over cos. So let me show you. Tan is equal to sin theta over cos theta. Sin theta over cos theta. So we have written just 7 tan theta. Instead of tan theta, we have written sin theta over cos theta. Okay. We have written sin theta over cos theta, and the denominator cos theta, this is unchanged. We have written here unchanged, plus 12 equal to 0. After that 7 sin theta cos into cos square theta plus, if we simplify, look at this, our denominator is going to be cos square theta. This 2 means cos square theta. Then if we multiply by 12, it's 12 cos square theta equal to right side. You know how to simplify this. I think all of you are well versed with such algebraic calculation. Then if we do cross multiplication, this cos square theta into 0, it will be 0. Right side is going to be 0. On the left side, whatever there is denominator, because denominator will be multiplied by actually 1. This is called cross multiplication. So by 1, if you multiply the numerator, it will remain as it is. There will be no change. So 7 sin theta plus 12 cos square theta. And cos square theta, look, this cos square theta, there is a formula we know. Cos square theta means 1 minus sin square theta. So it is a vital point of this solution, that we should know that cos square theta is equal to 1 minus sin square theta, and sin square theta is equal to 1 minus cos square theta. Okay, let's move on to the next part. So so far what have we got? 7 sin theta plus 12 into 1 minus sin square theta. If we simplify it, we get 7 sin theta plus 12 minus 12 sin square theta. We can standardize this, that means it can be rearranged. So as per the order, so this is containing higher order. So negative 12 sin square theta plus 7 sin theta plus 12, we have just rearranged. Then this symbol, look at this, we are going to simplify this symbol. If we multiply every symbol by negative symbol, then it is going to be 12 sin square theta minus 7 sin theta. This symbol will be turned to, that means every symbol is going to be interchanged. It will be positive and it is going to be negative. So ultimately what did we get? They told us to show that 12 sin this one 7 tan theta over cos theta plus 12 is equal to 0, should be expressed as 12 sin square theta minus 7 sin theta minus 12. So we have got the answer. That's why we have written here shown. As we have showed the answer, so we have written here shown. Let's solve the immediate next question. The next question says, hence solve the equation, that means the previous expression, actually 7 tan theta over cos theta plus 12 is equal to 0, and we have just proven that 7 tan theta over cos theta plus 12 equal to 0 means this portion. Just we have proven here that it is actually 12 sin square theta minus 7 sin theta minus 12. So let it be written instead of this. We have written over here, look, we have written 12 sin square theta minus 7 sin theta minus 12 equal to 0. From they have mentioned that, hence we can reuse this expression. So this is our expression is now, equation is now 12 sin square theta minus 7 sin theta minus 12, and you know how to factorize this. For solution in most of the cases, this is quadratic equation, as there is square. So for quadratic equation we will have to factorize, we will have to convert into linear factor, then we will get the roots. So 12 sin square theta is this 12 and 12 is actually 144, and if we multiply 16 and 9, it is going to be 144. So we can split the middle term into these two parts, negative 16 sin theta plus 9 sin theta. This is actually the core part of algebra, and I think all of you are well versed with such manipulation, algebraic calculation. So 12 sin theta and the second 12 sin square theta and 16 sin theta. Between these two, 4 sin theta is common. If we take 4 sin theta as common, it is going to be 3 sin theta minus 4. And in the next pair, only 3 is common. If we take 3 common, it is going to be 3 sin theta minus 4. So ultimately we have got two linear factors. One is 3 sin theta minus 4, another one is 4 sin theta plus 3. Now out of these two, actually we cannot accept both of the values of both of the factors, because look at this, we know sin theta, that means negative 1 equal to sin theta until plus 1. Remember, the value of the, that means y coordinate or range of the function will the range of the function is from negative 1 to 1. Now let's see, if we choose this one, that means the first factor is this, 3 sin theta minus 4 means 3 sin theta is equal to 4. 3 sin theta is equal to, let me write over here, see, 3 sin theta equal to 4, whether this is acceptable or not. As this is transformed, so let us multiply, it is going to be negative 3, here amplitude is 3, so 3 sin theta, 3 sin theta, 3 ones are 3. That means the range of this function is actually from negative 3 until 3. It cannot exceed the range. So look at this, if our range is 4, I mean y coordinate is 4, is it acceptable? Not at all, because the range is starting from negative 3 to 3. That's why this is actually not acceptable. We have rejected this value. So remember, whether sine or cos, our range is from -1 to 1. So if any value exceeds this limit, then that is rejected. That's why we have rejected the first factor, 3 sin theta minus 4. This is not acceptable. So what is remaining there? The next factor is 4 sin theta plus 3. We have written 4 sin theta plus 3 equal to 0. That means sin theta is equal to -3 over 4. Now let's see. Let me write over here. We have written sin theta is equal to -3 over 4. Let me erase the unnecessary part of this solution. Well, sin theta is equal to -3 over 4. That is, theta is equal to sine inverse of -3 over 4. So first of all, we will have to decide which quadrant contains negative value for sine. From the previous solution, I think you have heard that sine is positive either in the first quadrant or in the second quadrant. So in the first quadrant, first of all, we will have to find, using our calculator, we can find the sine inverse of 3 over 4. Sine inverse of 3 over 4 is actually 48.6. Using my calculator, I got this. You can also do so. 48.6 is our basic angle. Now let us see the domain. What is the domain? Our domain is, look at this, domain is from 0 to 360 degree, from 0 to 360 degree. And look at this, this is actually original sine graph. The previous question, don't get confused with the previous question. Previous one was not simple theta. Here it was actually transformed, means it was enlarged function or enlarged sinusoidal graph. But this one is original function or original sine function. That's why the theta will be applicable. We don't redefine the domain. Remember, if the graph is original sine function or cosine function or tan function, whatever, then we don't need to redefine the given domain, as the domain is given from 0 to 360 and it's all about positive value. Okay, so only anti-clockwise direction. For positive, you may remember, I have already told, for positive value or positive root, we will move on to anti-clockwise direction, this way, anti-clockwise direction. This way you may make many cycles on the basis of the function, but it will be anti-clockwise direction. Okay, but for if your domain allows negative, then you will go to the clockwise direction, this way. Okay, so here our value is, look here, sine inverse of negative, that means value is negative. So first of all, we will have to find out that in which quadrant sine is negative. So sine is negative in this quadrant. We know sine is positive for the first quadrant as well as the second quadrant. As the value is negative, so it will fall either here or here. First and second quadrant is not applicable in this case, so only third and fourth. So all the discussion we are going to do is about third and fourth quadrant. The either angle will be this one or angle will be this one. And we have already decided that our basic angle is, using our calculator, our basic angle is 48.6, 48.6 degree. Okay, now already we have decided that we can move only in anti-clockwise direction. So anti-clockwise direction, what will happen to this angle? Look, up to this is 180 degree in the second quadrant. Now there is something more, means this angle is 48.4, 48.6. So for this portion, what will we do? First there is 180 up to the second quadrant, then we will add up this 48.6. So we have done 180 plus 48.6. What about the next? Already we have decided that fourth quadrant is also applicable, because our range is 360. Look at this, it may be any value among 0 to 360. That is, starting from 0 we can accept 360 until 360. So this is 360, even less than 360. So it is going to be from here, if we continue up to this is 360, but our angle will end up to here. Okay, so how much is this? From 360, if we subtract this portion should be subtracted, which is 48.6, means basic angle. So from 360, if we subtract 48.6, it is going to be produced to 28.6. If we add up 48.6 to 180, it is going to 28.6. And if we subtract 48.6 from 360, it is going to be 311.4. And there is no more value acceptable at all in the given domain. So remember, domain is the most important part of trigonometric practical solutions. Always we will look at the domain cannot be ignored at all. So simply, if I tell in brief, if you find that the graph is simple sine theta cos theta or sine x cos x or tan x whatever, then that is original graph or function. You don't need to redefine the given domain. But if you find that it is given sine 3 theta or 4 theta or 3 alpha or half alpha, these are the actually transformed graph. If the graph is transformed, then you will have to redefine the given domain. So in this case, there is no necessity of redefining the domain, because this is original sine graph. It is here we can say it's simple sine theta. So simply we can find out the values. Then for negative value, here the value of sine is negative. For negative value, sine falls in the either in the third quadrant or in the fourth quadrant. For third quadrant, we will add 180 to get the value of the angle. For fourth quadrant, we will subtract from 480, from 360 we will subtract the basic angle. That's all about this. I think it has been more clarified than the previous one. Let's solve one more problem. This question belongs to paper 060611, May June 24, and our question number, let me show you the question number. Question, we are going to solve question number 8. This is question number 8 from 0606 11. So the question says 4 sine square into 2 alpha minus pi over 3 is equal to 1. Again, look at this. This is also a transformed curve, because this is not simply written sine alpha. It is written sine square twice alpha minus pi over 3 is equal to 1. So this is a transformed graph, transformed function. We will have to be very careful while solving this. Let's start the solution. First, we have written the question 4 sine square into twice alpha minus pi over 3 is equal to 1. Then if we transpose this 4 to the right side, it is going to be 1 over 4. Then sine into twice alpha minus pi over 3 is equal to plus minus. Remember, whenever square root is applied, then both the positive and negative values should be chosen, and you know it very well. This is the tiniest and earliest part of algebra. So sine 2 alpha minus pi over 3 is equal to positive negative half. Then if we transpose sine to the other side, our now our root is this. Okay, twice alpha minus pi over 3 is equal to sine inverse of positive negative half. Okay, then twice alpha minus pi over 3 is equal to, we will find the values and the direction. Okay, let me draw the first of all, look at this. Our root is, this one is transformed. I think you remember from the first solution, whenever the graph is transformed or function is transformed, then we will have to redefine the domain. Let's see what is the domain. The domain is over here. It's written, domain is from negative 5 pi until positive, from negative pi over 2 until pi over 2. Let it be written. So this is our given domain. Now we are going to redefine this. First of all, it is written 2 alpha. So we will multiply every side by 2 alpha. If we multiply, it is going to be negative 2 alpha over 2, then 2 alpha and 2 pi over 2. So on the left side, what is it going to be? Negative pi, negative pi. Then there is something translation also, negative pi over 3, negative pi over 3, then twice alpha minus negative pi over 3, and here 2 and 2 can cancel out, so pi minus pi over 3. After simplification, let's see what it becomes. After simplification, we are going to be 3 and 1. There is 1 pi and 3 pi, means negative 4 pi over 3. Then it is twice alpha minus pi over 3 until that is here 3 pi minus negative 1 pi, so it is going to be 2 pi over 3. This is our redefined domain. Now if we convert it into degree, look at this. Redefining the domain is not the part of your solution. If you are very smart, you can do it mentally also, but for better understanding I am just expanding it, taking few moments from you. So it is going to be 6 negative 240. If we convert it into degree, it is going to be 240, because a degree is more convenient for us in case of choosing the quadrant. That's why we are just doing this, but this is not the part of your major solution. Then twice alpha minus pi over 3, and here it is going to be 6120. So this is the redefined domain for us. Let me write the redefined domain on top. Before that, I will have to erase this unnecessary portion. So our domain is from negative 240 to 120. Means both the clockwise direction, anti-clockwise direction, as well as clockwise direction, both of the values will be accepted. So we should not forget that for anti-clockwise direction the value will be positive, for clockwise direction value will be negative. So let's see first of all which quadrant does this is about sine. Okay, sine is, and basic angle half, sine inverse of half is actually pi over 6. This is basic angle. Okay, this portion. Now we will have to decide first for positive value. Let's choose the positive value. For positive we will have to move anti-clockwise direction. Okay, let's see. This is for positive half, and which quadrant does contain sine as positive? The first quadrant as well as second quadrant. Either this is the angle or this one is the angle. So if this is the angle, then it is going to be pi over 6. We have written here pi over 6. For the second value, if it falls in the second quadrant, then what will happen? In the second quadrant, angle is actually this portion, this is the angle. So this angle means total, we know from first from here to here the angle is measure is 180. So from 180, if we will just subtract this portion, okay, only this portion should be subtracted. If we subtract, we have written here that pi minus, but we cannot ignore our extreme bound, that means upper bound. Maximum it will be 120. Look, for positive maximum it can be 120, but if we move in anti-clockwise direction up to this, it is going to be 180 minus this one is 30, means 150. But our domain is, upper bound of the domain is 120, so 150 is not accepted. That means we cannot accept the second quadrant. So from in anti-clockwise direction for positive value, we have got only one value. Now we are going to talk about the anti-clockwise, sorry, this was anti-clockwise direction for positive value. Now we will move clockwise direction, whether this is possible or not. Let's see what is the anti-clockwise limit. I mean clockwise limit, negative limit. Negative limit is negative 240. So let's see, if we start from here, then it, how much is this? Yes, it is, look, it is up to this is up to this, it's pi, means 180, and this one is our 30. Okay, so 30 plus 180 means 120. So this is acceptable. How can we write? We will write in anti-clockwise, and in clockwise direction it's negative. So we have written here negative pi, then this angle should be added. Okay, this angle should be added. The, how much is this angle? This is pi over 6, basic angle. So we have added negative pi minus pi over 6, means the symbols are same. That's why it's addition. Actually for addition, symbols should be same. Okay, this is about the positive value of sine, that means sine positive half. Now we are going to find out the sine inverse of negative half. Let me erase this. For a negative value of sine, the value will be in either in the third quadrant or in the fourth quadrant. Either this is the angle or this is the angle. First of all, we will find the positive domain. Positive domain is not possible in this way, that means anti-clockwise direction. Then for clockwise direction it is possible. Look at this. For clockwise direction, lower limit is negative 240. So anything, any value upper than negative 240 we can get. So look at this. This is actually in clockwise direction, it is going to be negative pi over 6, means we are moving clockwise direction for negative value. So this is pi over 6. What will happen in this case? It is going to be negative pi plus pi over 6, because up to this it is pi. From pi we will have to subtract this portion. Actually our angle is up to this. Okay, our angle is from up to this. So from 180 we will just subtract this portion. This portion is pi over 6. So for subtraction we will have to use different symbols. That's why we have written here negative pi plus pi over 6. So that's all the four values. There is not a single value more which fits in the given redefined domain. So that's all the values. Now we will just simplify and solve this. So twice a, on the left side there was twice a, this is twice a, and right side we are going to transpose this negative pi over 3 on the right side. So we have written pi over 6 plus pi over 3. This is one of the values we have got. Then the second one was, look here, negative 6, negative pi and negative pi over 6. So 6 ones are 6. 6 plus 1 means 7. So this is going to be negative 7 pi over 6 plus pi over 3. From the left side we have shifted it to the right side. Second value. Third one is this one, negative pi over 6, and from left side we are transposing pi over 3. Then the fourth value is this one. This one is going to, if we simplify, what is it going to be? 6 ones are 6, negative 6 plus 1. From negative 6, if we subtract 1, it is going to be negative 5 pi over 6. Then from the left side we are just transposing pi over 3. So let's calculate this. Here it is going to be 6, 1 pi minus 1 pi plus 2 pi means 3 pi over 6, this one. Then this one is negative 7 plus 2 means negative. This is simple calculation, you know how to do addition subtraction of the fractions. And then next one is from 7 pi, if we subtract 2 pi it is going to be 5 pi. And if we do the third one, it is actually negative 1 positive 2, so it will be positive 1 pi. Then in the next case, positive negative 5 plus positive 2, it is negative 3 pi. After that we are going to transpose these two. Look at this. These two will be on the right side. If these two come to the right side, each of the solutions of right side, it is going to be 2 6s are 12. So everyone is going to be 12. Everywhere there is 6, so 6 2s are 12. Everyone is 12, and numerator is going to remain as it is, unchanged. We are not even touching this. Then what is it going to be? If 3 cancels out 4, 12, it is going to be 4. It is 4. So we have written pi over 4. Then here a cancellation is not possible. Here also there is no necessity of cancellation. And in the second one, I mean the fourth one, look at in the fourth one, 3 can cancel out this 12. It is going to be 4. Finally, what have we got? First one is pi over 4. Second one is negative 5 pi over 4, 12. And third one is pi over 12. Fourth one is negative pi over 12. Now, up to this, it is sufficient for you to write as answer. But it looks good mathematically if we write in order. So the lowest value is here, actually this one. This is the smallest of all values. We have written first the negative value, smallest one. Then the second smallest is this one. We have written this here. Then the third one is pi over 12. this one. Then the greatest of all values is pi over 4. So that's how we will have to solve this. That means the point which should be noted and accepted as well as imbibed in your brain is that positive and negative direction. Look, positive and negative direction. For negative direction you will move clockwise direction, okay, and for negative value you will move clockwise direction, and for positive value you will move anti-clockwise direction. Then you will have to know which quadrant is applicable for you, okay, after redefining your domain. For sine, first one is positive for sine, second quadrant is also positive for sine, third one is positive for t. First one is actually positive for everybody, is sine, cos, tan, everybody, and inverse of them, all of them are positive in the first quadrant. In the second quadrant only sine, in the third quadrant tan is positive, and in the fourth quadrant cos is positive. After that you will decide whether you should move in anti-clockwise direction or clockwise direction. If your domain allows the negative value, then you will move clockwise direction. But if your domain doesn't define any negative value, then you will move on to, for positive value you will move in anti-clockwise direction. I think it has been better than the previous ones. If still you have any query, you can ask me through WhatsApp. I have already attached the WhatsApp number on the thumbnail. Let's solve the last of all questions of today's session, and the question belongs to, you can see here, it's 13 06. The paper code is 060613, May June 24. And let me see the question number. The question number is 12. This is our question to be solved. The question says solve the equation sec 3 theta minus pi over 2 equal to 2. And you may remember this is also a transformed graph. This is not simple sinusoidal graph or function. This is transformed function. Uh, First it has been enlarged with the scale factor of 3, then it has been translated. So let's start the solution. Let me zoom in the picture. The question is sec 3 theta minus pi over 2 is equal to 2. Then we know is actually sec theta and cos theta, they are reciprocal to each other, okay. So instead of sec we have written, it should not be forgotten, all of you know I believe, that sec is inverse to cos, and sine is inverse to cosec, sine theta is inverse to cosec. Well, that's why we have written, instead of sec we have written 1 over cos this. Then if we do cross multiplication, it is going to be, or cross multiplication or reciprocal, if you reversed you will get cos 3 theta minus pi over cos 3 theta minus pi over 2 is equal to half, okay. After that we are transposing this cos to the right side, it is going to be cos inverse of half, and it is positive. Then as we have already discussed about the domain, this domain will not be applicable for our solution because this is a transformed curve, a transformed function. That's why we will have to redefine this domain. Let us write the domain given. The domain is given negative half until positive half pi, positive half pi. So how will we transform? First there is this is our root, so 3 theta. So we will multiply every side by 3, negative 3 pi over 2. Each of the parts will be multiplied by 3, 3 theta, then 3 pi over 2. Then after that there is translation of this negative pi over 2, negative pi over 2. So negative 3 pi over 2 minus pi over 2, 3 theta minus pi over 2, then 3 pi over 2, 3 pi over 2 minus pi over 2. Let's simplify this. It is going to be negative 3 positive 1. So sorry, negative 3 negative 1. So it is going to be negative 4 pi over 2, and this is 3 theta minus pi over 2, and it is a positive 3 negative 1. Positive 3 negative 1 means positive 2. 2 pi over 2. If we convert it into degree, it is going to be 2 pi. 2 pi means 360. Negative 360, because 2 can cancel out the other 2. 360 degree to thrice theta minus pi over 2, and here that is, if 2's are cancelled with each other, then there is pi. Sorry, pi means actually 180 degrees. So our domain is ultimately from negative 360 to positive 180. Let me write the domain on top of this, and before that I'm going to erase this portion. Now we will draw the quadrant so that we can decide which values are to be accepted. So first of all, 360 degree negative. Look at this. This is the domain is negative. So for negative, we can move on in clockwise direction. Clockwise direction. And for positive, we will have to move in anti-clockwise direction. So both directions are applicable in this case. Let us see our basic angle. Basic angle cos half is equal to actually 60, means pi over 3. Pi over 3 is our basic angle. That means this is pi over 3. Pi over 3. This is pi over 3. Well, now first of all, as the value is positive, look here, it is actually positive half. That means we for cos positive angle falls either in the first quadrant or in the fourth quadrant. Now let's move on to the anti-clockwise direction for positive value. For positive value, first one is pi over 3. We have written here pi over 3. Pi over 3. Then let us see whether this is applicable or not. In this quadrant, the value must be more than 270 or less than close to 360, and our positive upper domain upper limit is 180. Positive upper limit is 180, so we cannot accept this one. This way it is not possible. Then we have done in anti-clockwise direction. What about clockwise direction? In clockwise direction, if we move this way, let's see whether the values are allowed or not. So this one is negative pi over 3. We have written negative pi over 3. Then what about the this one up to this? This is 360, negative 360 plus, pi over 3 means 60. So negative 360 minus 60, that means it is greater than 360, so it is applicable. We can allow this value in clockwise direction. We can receive this. So this is actually 2 pi. 2 pi minus whole of this is 2 pi. So from 2 pi we will subtract this. As we are moving in anti-clock in clockwise direction, this is negative. So negative 2 pi plus pi over 3. After that, we should check out whether we have got all of the values required. So in clockwise anti-clockwise direction, anti-clockwise direction, we have got only these angle, because these, if the angle falls over, sorry, if the angle falls in the fourth quadrant, it is around 360, which is not allowed. We do have only 180. So maximum 180 or less than 180. So anti-clockwise direction only the first quadrant. Then in anti-clockwise direction, the first quadrant is applicable, because this is negative pi over 6. Pi over 3 means 60 degree, which is in the range. And then the in the clockwise direction, the first quadrant again is applicable. How? If from 360 we have subtracted this 60, and we got that this value is in the range. Then after this, it is from left side. Let me zoom it out. if we simplify this pi over 3, and from the left side we are going to transpose this negative pi over 2 on the right side. So we have added over here, with everybody, pi over 2 has been added. And look at this, in the third one, this is 3 2s are 6, 3 2s are 6. From 6, if we subtract 1, it is going to be negative 5 pi over 3. Then from left side we have brought this pi over 2. Then let's do simplification. It is going to be 6 and 3 pi plus 2 pi means 5 pi. Then here negative 2 positive, sorry, negative 3 positive 2. So from, sorry, negative 2, it is going to be negative 2 and positive 2, negative 3. So it is going to be actually negative 2 positive 3 means 1, positive 1. Then in this case, negative 3 positive, sorry, negative 2, negative 10, sorry, negative 10, negative 2 5s are 10, negative 10 and positive 3 means negative 7 pi. After that, it is going to be, look, this 3 is not to be on the left side. If we shift it to the right side, it is going to be 3 6 are 18. All of them are 18 because all of them are 6s, and the numerator will remain as it is. There is no change to the numerator. Last of all, we have just standardized, that means this is the smallest of all value. That's why it has been written first, then the second lowest value, then the greatest value. So ultimately we got that there are only 3 roots of this theta. So what have we learned from this? I think so long you have understood all tiny and complicated parts of trigonometry, that it is all about the domain and direction. For positive direction, you will move in clockwise direction, for positive value clockwise direction, and for, sorry, for positive, for negative value you will move clockwise direction, and for value, for negative value you will move clockwise direction, okay, and for positive value you will move in anti-clockwise direction. After that, you should not forget that in the first quadrant everybody or all angle is positive, in the second quadrant only sine, and in the third quadrant only tan, and for cos the fourth quadrant is positive. Well, and then you will redefine. If you find that this is only theta or only x, then this is original sine or cos graph. But if you find that this is either 3 theta or 2x, then you will have to redefine the given domain, and on the basis of given redefined domain you will have to find out the values. Otherwise you will drown in the oceans of confusion. So it's my belief and confidence that you have learned some of the basic and vital parts of trigonometry from this video. If the video benefits you in the least bit, please pray to the Almighty Allah so that Allah bless me more and more in the upcoming days. So, fi amanillah.